mathematics, a radical expression is any expression containing a radical symbol. However, it can also be used to describe a square root, cube root, fourth root, or higher. This symbol is the radical symbol, and under the radical symbol is the radicand, and the index defines the root to be taken.
So now we will tackle about on how to find a root of a number, and first is the square roots. So here in the examples, we can say square root of 100 and square root of 18. So we will solve the square root of 100 first. So in order to find a root of this number, we should find a number that when multiplied by itself will result to 100. So let's try 10 multiplied by 10. So this will result to 100. So therefore, the square root of 100 is 10. But here in 18 is not a number that has a perfect square. So in order to solve this, we should find a factor of it that contains one perfect square. So let's say 9 and 2. So in here, we can get the square root of 9, which is 3. And since 2 has no square root, we will leave it inside the radical sign. So therefore, the square root of 18 is 3 square root of 2.
The radicand is the smallest possible integer and must not contain perfect and factor other than 1. The product rule for radicals states that for two radicals which have the same index, you may multiply the two radicands and place the product under a radical with the same index as the two original radicals. For example, square root of 4. It will result to 2 because when we multiply 2 itself, it will result to 4. Next is square root of 12. Since 12 is not a perfect square number, we're just going to factor 8. So the factor is 4 and 3. Since 4 is the perfect square number, we're just going to square 8 and it will result to 2. At the radical because 3 is not a perfect square number. Next is 64a squared b to the 5th. Since 64 is a perfect square number, we're just going to square it and it will result to 8. There is a variable, so according to the rule, to simplify radicals containing variables, factor the greatest perfect power of the index, which would be the greatest multiple of the index. The denominator does not contain any radicals. It must be rationalized. For example, 2 over square root of x. We're going to multiply it to square root of x over square root of x because we're going to remove the denominator square root of x, which is having a radical. So it will result to 2 square root of x over x because the both denominators is square root of x and it will result to x when we multiply it. Next is 3 over cube root of 2. We're going to multiply it by cube root of 4 over cube root of 4 because we're going to make the number rational and will result to the value of the cube root. So the result will be 3 cube root of 4 over cube root of 8. And the simplification is 3 cube root of 4 over 2. The index of the radical must be reduced. Cube root of 16. So we're going to make it in exponential form. So it will be cube root of 2 to the 4th. So it will be easier to isolate exponent with the index. So the answer will be 2 cube root of 2 because we divide the exponent with the index. Next is cube root of 125 a to the 6. So we make the 125 in exponential form. So it will be cube root of 5 cube a to the 6. So we're going to simplify it and the answer will be 5a squared.
Thanks for watching!